So today I'm going to be looking at these two weak acids and determining which one is more acidic. So the first step to determining which is more acidic is going to be finding its conjugate base, which means that it loses a proton. So it's going to be HS minus for hydrosulfuric acid, and then it's going to be ClO minus for the hypochloric acid, I believe. Hypochlorous acid. Okay. So when comparing the acidity of these, well, we know which one is more acidic based on the strength, the stability of the conjugate base. So we know which one is more acidic based on the stability of its conjugate base. And when we're trying to find the stability of the conjugate base, we're going to be looking at size, electronegativity, and resonance. Okay. So first step is going to be to draw the Lewis for each of these. So for HS minus, it's going to be H, and then for that, we know we have, let's see, 2, 4, 6, 8 electrons. 2, 4, 6, 8. The negative charge is here, positive charge is there. And then I'm just going to write the electronegativities that I'll use later. 2.58, and then for sulfur, and then 2.18 for hydrogen. And then for Cl, we have Cl as the central atom, and then oxygen over here. And this is going to have 2, 4, 6, 8, 10, 12, 14. The negative charge will be on the oxygen, the positive charge will be on the chlorine. All right. Okay, so firstly we're going to compare the size. So we know that sulfur, which is the outer molecule, or sorry, the outer element attached to the central atom, we know that sulfur is larger than oxygen. So it is our expected larger, this is going to be our expected larger molecule. So basically, we know that HS is bigger than ClO just by looking at the periodic table. And we're also able to determine its size based on electronegativity. So oxygen here is 3.44 charge. Cl is 3.16. So the difference for Cl and O is 0.28. And then we have a 0.40 difference for HS. So the less difference in electronegativity, basically we have here a stronger pole we have a stronger pole of electronegativity from Cl than we do from S, therefore making it a smaller molecule. So as far as size goes, we know that HS is going to be bigger because ClO is basically being pulled smaller, if that makes sense. Okay, next we're going to compare electronegativity. Obviously, we know that this one is generally more electronegative, so that means that the Cl is going to be better prepared to accept the negative. It's going to want the negative charge from the oxygen better, therefore making it more stable. So we know that this one is more stable as a base. We also know that this one is going to be smaller. And then as far as resonance goes, we know based on this that the HS doesn't really have resonance because our outer atom hydrogen is it's positive and we only have one of it. So, and it can only hold 2 electrons. So there's really no resonance happening with the conjugate base of hydrosulfuric acid. And then for ClO minus, we know that oxygen is more electronegative, so it holds most of the negative charge. It does have limited resonance because it lacks another oxygen. Otherwise, it would have greater resonance, but this one does have more resonance than the conjugate base of hydrosulfuric acid, because this one has no resonance and this one just has limited resonance. So in total, we know that this one is more, HClO is more acidic because it has a more stable conjugate base based on the reasons that I just told you. So size is smaller, the electronegativity is greater, and then it has greater resonance.